Hey, what's up guys? Welcome back to C++ in 2021. Today we're going to continue our adventure into network programming with Boostazio by implementing a full chat client and server application. It'll set us up nicely for getting towards being able to do server commands and being able to do actual game objects. Right now we're just going to be passing in simple strings from one client to the other. Going through the server, but eventually the server is going to be holding some state and it's going to be taking more than just strings. It will also be taking binary data like structs and stuff like that. So if you're interested in the series continuing, the last video did decently, leave a comment down below letting me know what you're interested in, where you'd like me to go. Hit the like button, all of that nonsense, and let's just get right into it. One thing I almost always forget to mention in these videos is you can always get the source code for everything I go over at my corporate GitHub account, so GitHub/Mobile Technologies here, and this particular lesson will be under Moif, so mud on your face. Okay, so what we had last time, if you see here, I'm running the server, and if we run the client as well, you'll see that the server, I believe, only sends a message to the client and then just leaves the connection open, right? Hello, beautiful client, sends data, and if I kill the client, it detects a disconnection. So what we're going to do is we're going to reorganize all of these files to make it a little bit more robust, and so that we can send messages at will to the client and to all connected clients and all of that kind of stuff. So to start off, what we're going to do is we're going to reorganize a little bit of our stuff up here. We're going to move the TCP server connection stuff into a new directory called server, and we will just move these into here. We'll hit refactor just so it moves automatically changes the files. I'll show you where we'll do it again also in our source folder here. Alright, so we've renamed all of it. Right, now if you look inside our CPP file, the refactor, it automatically moved the header, and in our main.cpp as well. So just remember to do that if you're not in C-Line and it didn't do it automatically for you. So we're going to start in our server. I imagine there's probably not too much we need to change in here. Well, there's some, but let's just look at what we're doing here. So our TCP server itself doesn't need to change, the constructor. The run function doesn't need to change either. That one's okay. We will add things we will add. First, we'll remove all these listen callbacks because we're not quite there yet. That was just ideas that I threw out at the end of the last video that we're going to get rid of. So we'll get rid of that, and we'll make sure that there was none of that nonsense down here, which there was. So let's remove that. So we've got a pretty much clean basic server here. So we've got our run function. We've got our start accept function, which will definitely or likely need to update. And we also need a broadcast function, which will handle sending a message to all connected clients. So in our TCP server, right under run, we will do a void broadcast. And it will actually just broadcast a message. And let's just take that as a reference. First, let's deal with broadcast. Let's generate it. Let's move it up to where we want it underneath run. I like having stuff defined in the same order as my .h file in my CPP file, and that's why I did that. So notice how here we're creating the connection when we accept it here, and then we are pushing it into the array or the vector, and then we're starting our async accept, right? That's not exactly what we want, because here what we're going to end up doing here is you'll notice here that we're always accepting a connection on the same socket, right? Every time we go to create a connection, every one of the connections we make will go in here and it will restart the connection every time a new client connects. So you can't have multiple clients with this setup. It's actually not written well. So what we're going to do is we're going to make it so that we have we'll call it a dummy socket, an idle socket that's created, that's waiting for a connection. And when we get to connection, it will move itself into the connection itself to be used and then handled within that connection, if that makes sense. We'll work through it together. So the first thing we need to do is create a thing to hold that socket object, that temporary socket object. So if you go to our header file again in here, what we will do is we are going to create an optional socket object, which looks like, also one thing I'm going to do as well is, you notice this boost.asio stuff. I'm actually going to rename that IO equal boost asio, and that's just going to make it so that we can make stuff a little bit shorter. And let's put this in here, and then we can replace all this with IO, and that's just going to make it easier for ourselves as we move forward. Oh, not you. I don't need to do the namespace. I can just do this. Sorry, namespace IO equal boost asio. I just spelled it wrong. So what we want to do is we want to create this dummy socket object, right? So let's do that now. So what we're going to do is we are going to declare a std optional, and what this can be, it's going to be an IO IP socket TCP socket object called socket, right? And optional is not declared, so let's make sure to import that up here. And we're going to include optional. And then another other thing we will do is we're going to change this vector down here to actually, we're going to make this a unordered set. And we will also include that unordered set. And that's just going to make it easier to work with later. Oops. Right. So let's go into our TCP server and start rewriting our start accept function. So the first thing we're going to do when we start accepting a new connection, while we're waiting for a connection, is we're going to create a new socket object waiting on that IO context. So we're going to do socket.inplace. And this will take the arguments for initializing a new object. So this will just take our IO context. So this creates a socket that we're waiting on, and then we can actually wait on that socket instead down here. So you can reference it just like a pointer when you're using an optional. So you just dereference it with the star, and that will get the socket. And you know it always exists because we create it right above here. Now, once you get inside the function itself, that's when you're going to want to create the connection, right? So we'll move this down here. And instead of pushback, we're actually going to do insert because it is a set and not a vector. What else do we want to do? So we have, if there's no error, we don't need to bring in the connection anymore. So let's just bring in this. And then we start the connection. And then after we start the connection, we start accepting again. So this is getting closer. We are getting much closer. If we go inside this TCP create function now, if we go inside here and you look at TCP connection.create, which I guess I made up here, it creates a new pointer with IO context. This takes an IO context, and the constructor creates a new socket using the IO context, right? Now, what we're doing, we actually want to change this because we are using move semantics, which I'll try to, I might take a break from this networking project for a couple of weeks while we look over some of these concepts we're going over. But using move semantics, we can move the memory that's held by the optional in our server here that we created here into our TCP connection so that we don't actually need to create a new socket object once we go inside. So ideally what we would end up doing is we would do an std move here and dereference our socket like this. What this will do is when you do a move on an object, especially at most of the STL objects, what it's going to do is going to clear the optional, so the optional will become falsy, so there won't be anything inside, and it will move that object into wherever you're sending it. So in our TCP connection here, we're going to change our create pointer here to take a it's going to take a right hand value socket object, which is how you declare a move operation is happening. So it would be well, we did it using up here, but let's do again namespace IO equal boost ASIO. We'll do that, and our create function here is going to take an IO TCP IP TCP socket, and then it's going to be a double reference, which means a right hand value, and then it's going to be socket, right? So that's our new create function. Now we need to propagate that out to our TCP connection. So we'll just copy this again, and we will put this inside here, right? And we will go inside here and make sure that our concept is there, and we will put socket here. And then finally, with all that done, we're going to actually take our socket here. So notice if I just put socket here, it's going to give me an error, because once you move something in and it's right hand value, once you reference it again, it becomes a left hand value. So we need to forward it, we also need to move it one more time into our TCP connection here. And this again, I believe will need a std move as well. So that's how we move our socket from our server into our connection object. So that's how you move it in. You declare a move, create a right hand side object. So all this does, it converts the type into that double end type that we saw. So we convert that, we move it into our TCP connection create function, and then once this gets received, we move it into our TCP connection function, and then with that created, we move it into our socket object. And what that will do is it will have one initializer that will do everything for us, right? So let's go back to our server and see what else needs to be done. So with that done, we should be able to, theoretically, it'll go inside here and it will do exactly what it did before, but now it will work for as many clients as we want. So let's just play that and make sure that it is not dying. And I moved stuff, so I got to remember reload my CMake project. Perfect. So we have our server. Now our server is being hosted at 1337. With our client here, we can actually just do that quickly. Hello, beautiful client. And we can see here it does the same thing, sends 25. If we close the client, we'll do this here. Now, one thing we're going to do now that we're going to be disconnecting the client from the server a little bit, and it might not work properly, we are going to be switching to Telnet. Now I'm using the Ubuntu subsystem, or the Linux subsystem for Windows, or Windows subsystem Linux, or whatever they call it. I'm using that because Telnet works better. So make sure you have Telnet. You can get it on Windows by, if you go inside programs, if you go into apps and features here, it might be at the bottom here. Yeah, so at the bottom of apps and features, there's this programs and features. And here you'll find turn Windows features on or off. And in here, you'll see Telnet client. You'll want this if you're using the Windows one. And then you'll just open your command line and call Telnet like this. And you can do localhost 1337. And you'll see here that we connected just the same way as our client did before. And we can quit. And it detects that we quit properly, right? That's exactly what we want. Now we're going to be able to talk to each other using the clients, using this Telnet client for now. And then when we make our own client, we're going to just make sure it behaves the same way, right? Okay, so now we're going to work on the connection side of things a little bit before we move too much further. So we've got it so that we're taking in our socket object here, right? Now what we want to do is we also want to be able to kind of have a username a little bit for now for our clients, right? So what we're going to do is we're going to keep a connection name when we create the client. So inside our connection header here, let's remove this. We're going to store a name, and we actually don't need this message anymore because that's going to go away. So from in here, we're going to keep a string, and it's going to just say it's going to be our let's say our username, right? And then we're going to just grab the username now. So one thing we will need is we'll need to keep a error code. So we'll get the error code, EC. We will take a spot for we'll create a string stream that will hold the name. And what we will do is we will put the socket remote endpoint into the name, and then we are going to store the username as name.string. So this will keep our username on connection, and that's all we need to do in here. On start, we're actually going to rewrite this entire function, right? So we'll remove that, and we'll go into our function here. So this is our TCP connection as it is. Now, instead of doing everything within our start function, what we're going to do is we're going to kick off an asynchronous process. And why is this connected? Oh, right, this is not IO system, this will just be boost system, sorry. All right, let's build this. All right, with that being built properly, let's get back to my explanation. So what we need to do with our start function is we will gather the information we need from the client. So we're actually going to put some arguments inside our start function here, arguments, which will actually, these are going to be callbacks that we're going to call from our server or from our main application so that we can customize what our application is actually doing from our main server here. So we can make this a more generalized server. And from within the start function, what we're going to do is we are going to kick off an asynchronous read function, which will make sure that we're always waiting for a new message to read from the client, right? In addition to always waiting for a new message from the client, we're also going to need to be able to send the client new messages, right? So to be able to send a new message, what we're going to do is we're going to create a new function called send message, which is just going to take a const string reference message. Apparently send message is already defined, so we're going to call this post like I did in the repository. So this function here is going to post a message to the client, right? Now the asynchronous functions, what this is going to do, things are going to be a little bit more split up than you would probably think they should be, but our start function is going to call a function called void async read, and this is going to wait for a new message from client. And then once a new message is received, it's going to call another function called void onRead, which takes a boost system error code, and it also sends us the bytes transferred, the number of bytes that was transferred. Similarly, when we call post, what it's going to do is we're actually going to queue up messages, so you can request to send as many messages, but it's only going to send one at a time. But similarly, on our post function, what we're going to do is we're going to call a function called async write, which actually we're going to rename this one here to fit with the rest async read. just make it camel case instead. And we're going to call this async write. And similarly, whenever a write completes, it's going to call a function called onWrite, which is going to boost system error code, and same thing, bytes transferred. And that is all of the functions we need. Now, as I mentioned, when we write a message, we are going to write it to a queue. So the queue that we want to be writing to is going to be in a standard queue. So no need to repeat myself too much. And this will just be a queue of strings. And we'll call this outgoing messages. And queue is not declared, so let's make sure to include queue. In addition to that, if we go back here, let's go back to our TCP connection and actually just go back here. You'll notice here that we created a buffer here, and we prepared the buffer, and then we read into the buffer, right? Let's just put this all back. Similarly, when we read in our async read, we're going to need a place to store each message as they come in. So we're going to create a buffer inside here. So this one is going to be simple enough. It's going to be IO stream buffer stream buff. We'll call this stream buff. And we're going to initialize our stream buff object with a max capacity of 65536, which is a max int, I believe. Basically just so that our stream buffer doesn't just go on forever by accident if we make a mistake, and it'll cut itself off. So that's pretty much everything we need for our TCP connection object for now. We will come back to the callbacks later, and now let's just implement some of these functions. So first we will go through and we will just scaffold out all of this stuff. There we go. Save that. Okay, so under TCP connection, we're going to do first thing. As I mentioned before, all our start function is going to do right now is start our async read loop. And let's implement that loop now, and we'll come back to post after that. Our async read loop will be basically what we did before, but a little bit different. So it's going to be async read until. So I think I can do async read until, and then we give it the socket. We give it the stream buffer that we want to put the message into. Then we give it a delimiter, so it's going to read until it finds a new line. So it's going to read one line at a time, which is fine for our chat object. It's something we're probably going to go back to later as we make this more into a game. And what we did before is we made this a shared from this. So we're going to just make sure to say self equal shared from this. Then we give it the signature that it's looking for, which is basically exactly the same as what we gave our onRead function here. And then we will call onRead error code bytes transferred. And this will be self onRead. In our onRead function, it's going to be fairly simple. The first thing we're going to look for is if there was an error on the connection. So if error code EC is truthy, which means there was an error, what we're going to do is we're going to socket.close. We're going to close the socket. Now, one thing that can happen here is when you close a socket, it can throw an error. So if you don't want it to throw an error, you can actually give it an error code object where it will write its error into. Now, I'm not going to do that because I'm not going to check it afterwards because I'm not concerned about the error here, but just know that if you do it this way, here you could check again what the error was, if there was an error, and everything will work fine. And then here we would add an error handler. And this is where we would call one of the callbacks I mentioned that we're going to add to the start function. Just if there's an error, we can send that error to the calling function, we'll call it. Once we've determined that there's no error, we also want to return here to make sure we don't continue. Once we've determined that there's no error, what we're going to do is we're actually just going to read in the message, and for now we're just going to print it to console, but eventually we're going to pop that message out to our consumer. So we're going to do it pretty much the exact same way we did up here. So we're going to make a string message. We will, into our message, we are going to add our connection name. And then we will, not connection name, we called it username. So this would be, username. And then our username, and then we will create an input stream from our buffer, from our stream buffer, and then we will read from that buffer. Now, I'm going to pause here and just explain something real quick. And then, actually, before I continue, let's just print that message. That's our message here. And then add a message handler. And then at the end, we will kick off the next loop of our read so that we can wait for another message. And that's the basic loop. So it's asynchronous. So this is just going to wait on a thread. Now, the thread itself we can talk about later, but you can basically think that your IO context defined in your server here, your IO context, that's going to be generally what will consider your thread. It's technically an executor, but just consider it your thread for now. And we can get more in depth as we move forward. And we want to .string here, and we will put it on end line. Okay, right. So this read buffer thing. So in general, notice how we get this bytes transferred variable here. Now, usually what you would do is do something like a stream buffer consume, and you would do bytes transferred here, right? And this tells the buffer that you've consumed a certain number of bytes and that it can clear those number of bytes from the buffer. Now, I did some testing, and read buffer here actually under the hood calls a consume on the stream buffer itself. So this is actually not required in this case, but we can leave it there anyway. But just remember that if you call read buffer, it's going to consume the bytes on the buffer. So if you want to do multiple things with those bytes, you want to use a different function than read buffer. That's the point I'm getting to. Now that's our basic on read loop. This will be able to wait for a message from the client, and it will print it to the console. Now we should be able to test that already. Let's build this and see what it gives us. Okay, now I'll hit play on that. That should start the server, good. And let's go back to our Telnet connection. Let's say hello. And you'll notice here that it received the message and it printed the message. And I'm so cool, I've got a name. And now you'll notice here there's an extra new line here because since we read until there was a new line, our message actually contains the new line, so we don't actually need it. So let's just restart our server now. And now if we open it up, hello, my name is Molly. I have a lolly. Want to play with my dolly. See, and we have our chat message here. Now, right now, the server's the only one reading these messages, but it's a good start. So now let's make it so that we can send a message back to our client later. right? So if you notice here, when we do this, we send the message, but we don't get a chat server will generally echo your messages back to you. So for now, we will create our write function. So the first thing we want to do is post. Now what post is going to do is when you request to write a message to the client, it's actually going to queue it, and the queue will keep on running until it's out of messages. So what we're going to do is the first thing is we're going to say, we're going to keep it here, and is the queue idle. So is queue idle equal queue dot empty. So the queue is idle if the queue is empty. Then we will add to the queue, we go queue dot I forgot the push, I think. We'll push the message into it. Then if the queue is idle, we will kick off our async write loop. Right? So this is fairly simple to grasp. If the queue is empty, it's idle, we push the message into the queue, and if we probably called this outgoing messages, right? Yeah, we called this outgoing messages. And if the queue is empty, it's idle, we push the message into the queue, and then if the queue is idle, we start writing. If not, we assume it's already trying to write the queue out. So we'll go into our async write function here. Now this one's actually fairly simple as well. It's going to be very similar to what we did here. So we can actually copy this just to make it simpler. So instead of async read it until, we say async write. Now instead of the buffer, what we're going to do is we are going to say IO. We're going to create a buffer out of the front object on the queue. So outgoing messages dot front. Then there is no completion condition. Oops, I deleted too much. And then we create our function, which has the same signature as our onWrite, which is also the same signature as onRead, so we don't need to change anything. And here we change it to onWrite. And then we're done. So same thing that we did here, we're going to check if there's an error, and if there's an error, we will close the socket and return to the error handler. And then afterwards, what we're going to do is we're going to remove the message from the queue. So we're going to say outgoing messages dot pop, which removes the message from the front of the queue. And if the queue is not empty, we will kick off our write loop again. So if outgoing messages dot empty, and then let's put the not symbol at the front, we will say async write, and we will continue the loop. And that's our entire write loop. So now we will be able to write to the client. Now for this to work, we are going to need to implement our broadcast function here. So our broadcast function is going to be simple enough. It's going to be for, we're going to take the connection in our connections, and for each one of our connection, we will call post, and we will just post the message. Now that's just going to broadcast all the messages. Now this is still not going to quite work because as it stands now, nothing is calling this broadcast function. And this is where we're going to start going into our callbacks, and we're actually nearing the end of what we want to do here today for the server. So what we want to do is we want to be able to handle a few conditions from our server. So if we go back to our TCP server here, we want a few things to be able to be done on our server. And we're going to create a few definitions. First of which I have functional, which is good. We're going to need it. We're going to say using, we're going to create an onJoin handler. And what this is going to do, it's going to be called whenever a user joins the server. So stud function void TCP connection pointer, like that. There we go, that's better. So when someone joins a server, we want it to trigger this on join handler, sending down the connection to it. We also want a on leave handler. So when a user leaves the chat or leaves the server, we also want to be able to catch that. So you use on leave handler, and this will actually be the exact same definition. And finally, we also want to be able to define what will happen whenever the server receives a message from the client. So using on client message handler, and this will just be a std function void, and which will have a string inside, right? Now we need a place to store these. Now I'm going to use a very naive way of doing this. There's only going to be one handler per server, but you might want to do what we did in some of the other videos where you can register multiple handlers for the same events and all that, but I'll leave that as either something we do later or something you can do yourself later. So we will add a few public members here, and these are going to be public just because there's no reason for them not to be public, but we're going to create an on join handler, and we'll call it on join, on leave handler, on leave, and on client message handler, on client message. So with these three things defined, when we go into our server and we look at our start accept function, we can already start calling some of this stuff. So right after we create the connection, we know that someone has joined. So what we want to do is we want to say if on join. So if on join has been defined, we call on join with the connection. The other two we will leave for a minute here. I'll show you how these callbacks are going to work, right? So we know that if we look at our server, so with this defined, we can actually start showing you, I can actually start showing you how these callbacks are going to work before we implement the other two, which requires some changes to our TCP connection as well. So in our server project, you're going to see here that right now I just have server.run. The purpose of our handlers is so we can do server.onJoin, and this will be a TCP it'll be moif TCP connection pointer server, and then we can also do on leave, and we can also do server dot on client message, which is going to be a little bit different, which is just std string. We can actually make this a const std string reference message, like that. So we can actually pass in the functions from our application layer on what we want these things to do. So for now, we want to be able to get our connection name here. So we need to add a function here for being able to get our username. So we'll do this right underneath here. Let's just say inline const std string reference get username const return username, right? But we're basically going to return the username, and now in our main here we can actually just print it off. Std count user has joined the server, and we will go server dot we can just say get username like that. That'll work. I know it will. It should work anyway. Oh yeah, stood and line, and we'll add a new line. So now when someone joins the server, we'll get that message. So now let's play that and see what that gives us. And that should be fairly straightforward. We should see when we join the server, user has joined the server, and we get the username. And we still have it, so when we receive a message, it'll print it out as well. So we'll see that the names and stuff match up. So we have that. Remember to keep an eye out on this window here. We join, user has joined the server, hello. And there you go, you have a hello message here. All right, so that's how we're going to define our callbacks. Let's do the similar thing here. User has left the server. So when the user leaves the server, we'll get a message saying we leave the server. And on the client message, so whenever a message comes from the client, we are going to say server dot broadcast, and we will broadcast the message to all of the clients, right? Now the reason we want to also capture the server, right? Yeah, and we don't want to do that. We want to capture a reference to the server, and that will work. I know it'll work. So the reason why we can do it this way, now that we have a server object up here inside our networking library, is that if we want to say parse the message and like do game server things and then send message to client or whatever we want to do, this doesn't automatically make this a chat server anymore, is my point. So when we get a message from the client, which right now is just a string, but imagine if this was a type T or whatever, it was just a more generic type, then this would be much easier, right? So that's what we are working with here. So now, these are never going to be called because we don't call them in here. So what we need to do to make that happen is basically the last two steps we need to do on our server, on the server side of things. So in our TCP connection, we want to declare two new handler types. So above our TCP connection here, we will say using message handler equal stood function, stood function void stood string, and I did that wrong because I'm really good at function syntax sometimes. So the message handler, easy enough when it's just a thing that you can pass a string through, which is basically the message. It's the exact same thing as we saw on the server side, but which just popped up to the connection level. The error handler itself, you're probably going to want to get more intricate with it, but for now we are just going to make this a void function that has no parameters, so that we can just say there was an error, basically, which in this case, since we're closing the socket as soon as there's an error, it's analogous to a user leaving the server. So with that done, we need to change our start function to take these things in. So we're going to say message handler, and this is going to be a right-hand side variable as well, which is can be moved in, but we can also declare it inline, which is the intent. Message handler, and we will say error handler, again right hand side, error handler like this. And we will need a place to store these, so we will store these down here, which is going to be message handler, and error handler, error handler. And now we need to change our definition of the start function. And this is actually just going to be fairly simple. We are going to change the signature and we are just going to store them. So our message handler is going to be equal to S. We're going to move in the message handler from the parameters, and we are also going to do the same thing for our error handler like that. Then in our here add error handler, we can just say error handler, and same thing down here, error handler here. And finally, on our read, once we receive a message, we have the message handler here. We're going to say message handler message.string, and we can actually just remove that. So what that will do, just went a little bit quickly. So we stored our handlers inside our start function, and then when we receive a message through our async read on read, we either throw an error, or we say that an error has occurred, or we send a string down through our message handler, and we do the same error handling stuff on our write function. So with that done, what we will do now is we go into our server and we can add the final few things. So really all we have left to do is add our handlers in here, right? So what do we want to do? We want to pass in this, and this is going to be our message handler. So we say it's our string here, and we're going to make it a const string reference. And we're going to say message. And this is actually just going to be very, very simple. So we can do this in one line actually, because it's not that much. So we want to check that if on client message is defined, we will call on client message with the message, and that's going to be our message handler. For our error handler, it's going to be a slightly more complicated function. So we are in here, we are going to grab a reference to everything inside this function. We will create a weak pointer to our connection. So weak pointer to our connection. And since we could put parentheses there, but those are optional if there's no arguments. And here we're going to lock the pointer. Just make sure that the pointer is valid when we pass it in. Then we are going to say if the weak pointer or the shared pointer was reserved properly with using the lock, we will then remove the connection from the connection, which is why we changed it to a set. And if we properly found if the connection is still valid, the connection object is still valid, and we found the same connection object within our connections set, we then will check to see if onLeave is defined, and if it is, we will call onLeave. And that's our entire server. So now we should be able to, I've got an error somewhere. Let's see where, oh, right, I got to give it the connection, so shared. Well, that should be everything we need for our server. Let's build it to make sure that we didn't make mistakes along the way. Now this is still really being dumb. Error handler not found. What? Oh, one too many R's. My fault. Do that again. There we go. So we've built everything. Now let's run our client, right? Now, if everything went to plan, we should, so we saw that it joined. If we leave using the special keys, you see user has left the server, so it's detecting join and leave properly. And now let's check our messages. If we say hello, we get echoed back our hello message. And that tells me that we should be able to create another client now. Close that. And if I say hello on here, hi, I'm the new user, you'll see here it now prints, hi, I'm the new user. And then we can say, hello, new user. I'm so cool, aren't I? And you see they each have different IDs on here, and they're being passed around properly because they're being baked into the strings being sent around. But that is a working chat client. So that's great. That's our server. Now I'm going to create the client. So the client itself is going to be very similar to what we did with our TCP connection, actually. It's basically our TCP connection is a client for all intents and purposes, right? So for the most part, we can just use the same things, but we will rewrite it from scratch just to be thorough. So let's create a new folder inside our Moif networking, and we'll call it client. We'll also do it in our source folder. We will call this client as well. And we will create a new class called TCP Client. We will make sure that this does this in snake case because that's the convention I like for my file names. We'll add it to GitHub. We'll make sure that it didn't add it inside this nonsense because I always forget to uncheck that checkbox. Here, one thing I'm going to do is I recently learned that I can just do glob recurse.cpp, and that should be enough to do everything I need. Now in our TCP client, we will namespace it under Moif, and we will do the same thing in our CPP file, namespace Moif. And we will move this Moif, we will move this CPP file into our client folder, into our source, and that does not belong anywhere. And then in our main.cpp, we can do include Moif networking client slash client TCP client.h, and we'll just reload the project just to make it clear. Right now that should resolve that. So we're going to do the same type of stuff we were doing before. We're going to namespace io equal boost asio, and we don't have that included, so we're going to include boost slash asio.hpp. We are going to declare a message handler. So we'll do that using message handler equal stood function void stood string. And that will be good. So we want a constructor. I'm going to go a little bit quicker on this one because we've gone through a lot of it. So our TCP client will take a address and a port. So const stood string reference address and int port. Having trouble today a little bit. We will be able to run the client. We will be able to stop the client, and we'll be able to write messages to the client. String constant message. Right? For consistency, we'll call this post. For consistency with our server. Then on our private, we're going to have similar stuff that we had on the server. We're going to have void async read, and we're going to have void on read, which is going to have a boost system error code ec size t bytes transferred. Now we will just copy these and change this to async write and async read. Async write and on write, async write and on write. we will be able to define our message handler. So same thing as our server, we will say message handler on message. One too many S's up here. And then in our private fields, we're going to have many of the same things that we had in our server as well. So we're going to need an IO context that we're going to call IO context. And we will initialize that. We are going to have a socket, IO, IP, TCP, socket, and we will call this socket. Then we will have a resolver. We haven't gone over that, but the resolver will essentially resolve endpoints for you based on the names that you give it. So you can give it like localhost or google.com, and it will resolve it and will give you a list of addresses that you can connect to. Well, technically, it'll give you a list of endpoints that you can connect to. So that being said, we're going to create IO, IP, TCP, resolver, and we'll call it resolver. And we are also going to create a actually, we're not going to store the resolver. We are just going to store a list of IP TCP endpoints, which is under results resolver results type endpoints. And then we will need a same thing stream buffer to hold incoming messages. So stream buff, which again will be 65536. And then we are going to hold a queue of outgoing messages. So it's going to be std queue, std string, outgoing messages, and we'll initialize that to nothing. And we will include queue. There we go. So that will be our entire interface for our TCP client. So notice again, these are the same methods we had in our server. These are basically the same methods we had in our server as well, but instead of start, we are using run, and we are giving it the ability to stop the client because it's actually going to be running on a completely different thread. So let's implement all these functions. Let's put all of these into our CPP file. There we go. All right, so we have them all here. Now TCP client. A couple of things we need to. There's a few things that need to be initialized pretty much right as you construct your application, because there's no default constructor. So the first thing is socket, which we will give our IO context that we initialized before. We will also, actually that's pretty much it, I think. We will then also populate our endpoints by creating a resolver. So it's IO, TCP, IO, IP, TCP, resolver, and we initialize it with our IO context. Then we say we want to get our list of endpoints. So our endpoints will be resolver.resolve, and it's going to be not underscore, resolver.resolve. We will give it the address, and we will say std toString, and we will give it the port. And that will get our list of endpoints. For our running method, oops, forgot a semicolon. For our run method, all we're going to do is we are going to attempt to connect to the endpoints, one of the endpoints, and then if it is successful, it will, it will just start the read loop. So it'll be if, it'll be async connect, and it's not IO, async connect. We give it the socket that we want to connect on. We give it the list of endpoints that we got on the resolver up here. We then give it a lambda or a function pointer. which will return a error code, and it will also return the endpoint that it connected to, IP TCP endpoint. Now we're not really concerned with the endpoint itself here, but we are concerned that if there are no errors, then we will say async read. And at the end of all that, what we want to do is we want to do our IO context.run. Right? So if you remember from the last lesson, if you go inside here, we don't have an IO context here. I don't think. We are doing a socket read sum, we're reading one, and we're just doing a loop, which this was actually really badly done. So let's look at our main here. If you look at our server, which we did last time in a much better way than we did our client. When we start our server, we start the accept, which basically just defines our asynchronous functions. And then we call a run, which basically runs in blocks. So this will start the thread and will run until there are no more asynchronous operations in the queue. So considering that our connection is always waiting for a message, there will always be an asynchronous operation in the queue. Since there's something always in the queue, we can just assume that I didn't give this a name. We can just assume that IO context run, this will block here pretty much forever and will always keep on running. Now, one way to cancel all operations and to make this exit would be to close the socket, right? So what we are going to do is in our stop function, we are going to call a socket.close. Now, if we did this by itself in this naive way, it will almost certainly throw an error, which would bubble up the stack and actually make it look like your application is doing stuff you don't want it to do. So to prevent that error code from being thrown and bubbling up, we can do what we did before and define an error code object here and pass that into close. Now this will just silence any errors, and you could, if error code here, process error. And let's just add curly braces here, just so you know where that goes. Right? So that's our stop function. Our post function is going to be pretty much identical to our post function in our TCP connection. So again, we will just check bool is the queue idle is equal to outgoing messages dot empty. We will push the message outgoing messages dot push. We will push the message into the queue, and if the queue is idle, we will async write. Async read again is pretty much identical to our server connection as well. So all we're going to do is we're going to say IO async read until on our socket using our stream buffer, and we will give it a this pointer. Now the reason we're only giving a this pointer here is because we're expecting that we're expecting that this function or this client, that there will only ever really be one client on this thread, and the client will live until it's no longer needed. So we don't need to keep a shared pointer to the client because we assume that everything's working properly until the end. So again, we will take a boost system error code size t bytes transferred. And just like the other one, we will just say on read EC bytes transfer. Our on read function is going to be actually identical pretty much to the other one as well. So if error code, we will just close the socket, which we could actually just call stop actually, and we will call return. And then same thing here, we will string stream message. We will put the message into the, we will put the buffer into the message by creating an input stream of type, sorry, I'm getting a little bit winded here, stream buffer, and then we will actually, can I do this? Dot read buffer, yeah, like that. And then we will call our on message function, and then we will kick off the read loop again. Async write, again, identical to what we were doing before. So I don't know why this is mad at me. Oh, right. We didn't give it the delimiter character like this. And async write here is not what we're doing here. That's the next part. Async write, what it's going to do is it's going to basically do the same thing as this one. But we are going to remove the delimiter. And we are going to take the front of the queue and we are going to call async write. So we will write async write, take the front of the queue instead of stream buffer. So we say IO stream buffer, or IO buffer. Yeah, IO buffer. IO buffer. And we will take the outgoing messages dot front, and we will on write that. And then async write is just going to do that, and it's going to pop the messages. So outgoing messages dot pop, and if it's not empty, if not outgoing messages dot empty, we will async write. And that's our entire client. Now, we went through that quickly, but it's literally, it's 95% the same code as what we did inside our connection, with the added idea of we added a resolver. Then we run the context, we connect to the endpoint, and if there's no error, we start reading from it. We have a stop function that gets called from our on read or on write or on error, and yeah, that's pretty much everything. And we do a read loop, a basic read loop, a basic write loop, and that's our entire client. Now, the last final step of this video is to update our client. Now, what we're going to do here is we're actually going to remove the entire code that we put last time. We are going to remove everything except our TCP client here. And we will remove this because we don't want access to raw networking concepts. And we will keep IO stream probably because we'll want to be able to print stuff. So first thing we're going to do is we're going to using namespace moif, just so we don't need to type it over and over again. We will create our TCP client. So TCP client, our client will be, we're going to do it at localhost. So we should be able to do localhost. Let's try it. And we will say it'll be port 1337. So that's our client. We will define what we are going to do when we get a new message. Client.onMessage equal, we don't need anything, const std string message, and on message we're just going to print it. Just going to print the message. Now, this is pretty much everything we need to do for our client, because all the client is really doing at this point is listening for messages. Now we could just run the client like this, right? So we can do client.run, and that will run the client on this thread. So let's run our server, and let's run our client. Now, in theory, the client should be listening. As you'll see, the client is here, it's listening to one. It should be listening to messages. So if I go here and I say hello, you'll see that the client receives a message and prints it. Now we want the client to be able to talk, otherwise it's not a chat client, right? So let's do that, right? Stop the client. The server can stay running because we're done with the server. So the issue is that, as you saw, that this client.run actually blocks. This client.run blocks the main thread. So we need the network or the input thread to run on a separate thread. We're going to kick the client off to a separate thread for our purposes here. So what we're going to do is we're going to include thread, and we are going to wrap this client.run into a thread. SCD thread T, and we give it the client. We give it no parameters, and we just call client.run like this. Right? Yeah, that looks right. Now this will kick it off to its own thread. Now if we run this, you're going to see that if we just run this, it's just going to run quickly and then immediately exit because it's running on a thread, and it actually it creates an error because it doesn't shut anything down properly, right? So the one thing we want to do is, before we leave, we want to call t.stop. Not t.stop, we want to call client.stop. And client.stop will cause the thread to its context to stop, and then you can do t.join to wait for the thread to end before closing the application. So now, in theory, it should run the thread for a little bit, stop it, and quit the program. Didn't quit the program like it should have. Well, let's just wait a little bit. We'll go back to that in a second. We'll continue with the client. This should have worked. It worked in my testing. So yeah, so we'll just go back. We'll finish up the client, and then we'll see why this is not working. So now all we have to do at this point, assuming that this will work eventually, is we need to do an input loop so we can start sending messages. So we'll put it in a while true loop like this. What we're going to do is we're going to get a message from the input message, and we are going to get line like this, and that will get a line of input. We will then check to see if that message is a quit request. So if message equal quit, which is, we're just going to do backslash quit, and if it is, we will break. Otherwise, we're going to add a new line to the message, because remember the server, if you remember the server connection is reading until it finds a new line. Get line doesn't give you the new line character. So we're just adding that new line so that it will properly terminate or properly get caught on the client side or on the server side. Then we will finally call client.post, and we will post the message. Now we should have a working client. So we got this here, we say hello, and we get the hello message. Now let's go inside here, hi. So we get the hi message, we say hello there, and we get the hello there message. So it's communicating properly. And if we want to quit, we hit /q, and it quits properly. So what I'm guessing is happening here, if I had to guess, is this is spinning up, but client.stop is being called so quickly that the client is not connected. Yeah, that's my guess, is that it's just going too fast. It's a slight race condition. But realistically, since we've got other things going on, this works fine. So if we didn't put this client.stop here, and we didn't put this here, you'll see that we get an error. You'll see that we get an error here. And if we quit, we get an error. It tries to quit the program, but the thread is still running and it throws an error. If we just call t.join, you'll see that it will quit the input loop, but it will be stuck waiting for the thread to finish because we never called stop. So we're here, we call this, and you see now it's stuck in a thing and we're not getting any messages. And that's why we put in the stop function. Now if, let's not do this, let's say hello, you'll see that they all get the message, just like that. And so this is how you can do a simple chat server using BoostAsio in C++. I hope you enjoyed, or at least found this informative. And again, leave all the engagement crap down below, and I will see you next time.